is typically when you do anesthesia at a specific level, the first thing that is going to become anesthetized are the local nerve roots, the nerve roots that are at that level. So you lose those, and then you lose what's below them when you do this. Does that make sense? Are you with me on that? Do you see what's going on there? Okay. So you should understand this general layout and structure. Yeah?
Lumbar or thoracic that they usually do the...
Lumbar, typically. Yeah. I mean, if you're talking about delivery, it's lumbar.
No, surgery. If you're talking about the surgery from breast endo...
Most of the time it's lumbar.
Okay.
Yeah. And there's a good reason for that, because, you know, above that,
but maybe the last one of thoracic.
Through that lumbar thoracic region, but most of the times, if they're going to do epidural, it's going to be lumbar. So here's your cord. And here we have the nerve roots coming out, or going in. The dorsal root, the ventral root. Okay? The dorsal root is sensory. Is that afferent or efferent? Afferent. The ventral root is motor. It is efferent. So when I said going in or coming out, that's literally what I mean. This is a spinal nerve. This spinal nerve will be named typically for the vertebra that it's adjacent to as it comes out. So we might call that, you know, T4 for the fourth thoracic, whatever. All right? And it has a motor component and a sensory component. Now the important thing that should help you remember which is motor and which is sensory is the dorsal root ganglion. What's a ganglion? Yeah?
A collection of neurocell bodies.
Cell bodies, exactly. And these cell bodies are all of sensory nerves. The cell body is here, the receptor is down here, and the synapse is going to be in, is it going to be in gray or white matter? So it'll be in gray matter. White matter typically is what? Fiber tracts. It's myelinated fiber tracts. All right? So we've got the dorsal root ganglion, and the ventral root. They come together very close to the spinal cord to form the spinal root. This is the spinal root for the spinal nerve. Okay? Now it's showing you here a very simple reflex arc. Signal comes in, gets into the gray matter. This blue neuron is a neuron that connects a sensory neuron to a motor neuron. These can connect any neuron within your nervous system to any other neuron, and they're called interneurons. Interneurons are between neurons. So with this simple reflex, signal comes in, you'll notice this. This is taking the sensory signal up to your brain. However, this distance is much shorter. So, let's take you to a very simple reflex that many of you may have already experienced. There's a hot pot on the stove. Okay? I don't know about you, but sometimes I forget. You go touch the hot pot. your hand pulls away, and then all of a sudden you feel the pain. Have you ever had that happen? That's weird. What's going on? Can you explain it to me? What's happening? That pot, let's say it's a tea kettle. Tea kettle. I have at home our tea kettle, one of those kettles that has a metal handle, which means you have to grab it with a tea towel or something, or a mitt. Or else if you grab it without that, you drop it and there's boiling water everywhere. Boiling water. It's 212 degrees Fahrenheit, 100 degrees centigrade. Is that hot? Damn right it is. You put your finger in boiling water, it starts to cook. We don't want that. Not good for you. So it turns out you have a reflex. Signal comes in to your gray matter. Signal is saying, this idiot is touching something that is boiling. Signal goes in two directions. One, it goes up to your brain. Oop, I better tell the brain we're about to boil his finger. And this other signal comes to a motor neuron that has you do this. The delay in time is the amount of time it took the signal to get up to your brain to say to the brain, oh, by the way, his finger's in boiling water. What do I do? Goes to another part of your brain and says, move the hand. Signal comes back down, the hand moves. Way before that signal starts bouncing around in your brain, that signal going to the brain, this signal comes through here and says, this is too important for the brain to get involved. We are making this decision at the spinal cord level. You pull your hand back, and as your hand is pulling back, you go, ow, that hurt. Did you ever wonder how that all worked? Why did I feel the pain after I started moving away? Because you don't feel the pain until the signal gets to your brain. And that's the lag time. That fraction of a second. Fraction of a second might be the difference between saving a finger and losing it. Well, you go, I got 10 of them. Yeah, like all of them, they all do something different. So, these reflex arcs become very important. Same thing, you trip. Okay? I know you might be one of those really clumsy people, you trip a lot. But you're not that clumsy. You trip, your foot lands in the right spot. Cool. Ever think about what's going on? That's really cool, that's really neat. Because when you walk, there's a lot happening. Number one, you're coordinating your left and right leg. One goes forward, as this one goes forward and it starts to hit the other one and picks up. But as this is going forward and I trip, I short circuit. This one's picking up. This leg becomes stabilized, it kind of becomes rigid, and this one goes to an angle from that leg that you couldn't calculate fast enough. Your spinal cord is really good at this. It calculates the angle for this foot to go so that you're stable, unless you're really clumsy and you face plant. That's really kind of neat. Or you're walking upstairs and you trip. Well, think about that. Every time you walk upstairs and trip, you should fall flat on your face. But you don't, most of the time. You trip once again, and how many times do you notice yourself tripping and that foot comes slamming down? Have you ever noticed that? Pay attention. You're falling asleep. You're sitting in the chair. You're going, okay, I'm not going to fall asleep in Kel's class. I must hear. Have you ever noticed that happen with somebody in a classroom where that foot gets thrown out and slammed? Every professor in the world knows. So-and-so fell asleep. All right? That's a reflex. And the reflex is to keep you from mashing your face. So you have all of these really neat reflexes. We'll be looking at more and more of the divisions within the cord. In just a minute, we're going to be looking at how the cord is divided up for gray matter, white matter, for motor pathways and for sensory pathways. So you should, however, as I believe I said earlier in first lecture, be able to look at something like this. This is easy to label, all right? This is not too tough. We're going to make it more exciting in a little while. So we have the spinal cord. Since you have a spinal cord, living tissue, right? Living tissue needs what? Blood supply. You have a fairly complex blood supply that's involved with delivering oxygen, nutrients, electrolytes to your cord. Now look at this once again. The cord terminates here. But this, what is this? You think this has a name, this area? If we think about the cord here, right? Here's the cord coming down. What's the brown space around the cord here?
CSF.
It's got CSF, correct. Therefore, what should it be?
Subarachnoid.
Subarachnoid space. Oh, look! Is this full of CSF? Yes, it is. Therefore, what do you think it is?
Subarachnoid.
It's subarachnoid space. Except the pia mater ends here. Okay? So this is subarachnoid. I inject into this, everything there is, it's quickly anesthetized. Up here, I'd be injecting into fatty tissue, so it slows down how the progression of all the anesthesia. So we have this rather complex group of anastomosing arteries. The spinal arterial plexus through here. Greater radicular thoracic radicular, the greater radicular. I don't care about Adam Kevich, right? You don't have to know good old Adam. You should know it's the great radicular artery, thoracic radicular artery, the cervical radicular artery. These are all branching off major arterial components of the aorta here, coming up here, the vertebral artery, all right? These are all involved with supplying the majority of what's going to become the spinal arterial plexus. We're going to see there are some 3 major arteries involved with this plexus. So, your cord structures here are surrounded by this plexus of arteries. Why? Why not just have, the arteries go as ones to everything? We have anastomoses here. Have we looked at anything that has anastomoses yet?
Circle of Willis.
The circle of Willis. Why do we have anastomosis there?
To ensure continuity of flow.
Constant flow, redundant flow. And here is your cord, really important. You darn well better believe it. You're not walking anywhere without it. Huh. Let's look at that. So here we have the plexal arteries. These are them, all around here, okay? Here is the anterior spinal artery. Here are the 2 posterior spinal arteries. And look at this. A circle. The circle not only is indeed just circular, it goes up and down levels. This is incredible. This is wild. We have 2 areas that are supplied blood flow, so to speak. We have this dorsal area, this dorsal or posterior arterial flow, okay?